Welcome to Module 4 Physical Layer. The physical layer of the OSI model sits at the bottom of the stack and it is part of the network access layer of the TCP/IP model. And without the physical layer, you would not have a network. This module explains in details the three ways to basically connect to the physical layer. And packet tracer activities and labs will give you the confidence you need to uh, cable up your own networks. So let's go ahead. Our first objective is purpose of the physical layer. Whether connecting to a local printer in the home or a website in another country, before any network communication can occur, a physical connection to a local network must be established. So a physical connection can be wired connection using a cable or using a wireless connection using radio waves and other mediums. So the type of physical connection used depends upon the setup of the network. For example, in many corporate offices, employees have desktop or laptop computer that are physically connected with cables to a share switch. So this type of setup is a wired network and data is transmitted through a physical cable, right? And in addition to wired connection, many business also offer the wireless connections for laptop, for tablets, for like smartphones. And with wireless devices, data is transmitted using radio waves. And we also know that wireless connectivity is common as individuals and business alike discover its advantages. And devices on a wireless network must be connected to a wireless access point, also known as AP. And wired connection to wireless router basically use NIC, network interface cards, and network interface card connect to device to the network. Ethernet NICs are used for a wired connection, and whereas wireless local area network VLAN, WLAN are used for wireless, and end user devices may include one or both types of NICs. And a network printer, for example, may only have a Ethernet NIC and therefore must connect to the network using an Ethernet cable, right? So other devices such as we can say devices, tablets, phones, smartphones, and might only contain a WLAN NIC and must use a wireless connection, right? And the OSI layer provides the means of transport, the bits that make up a data link layer frame across the network media. And this layer expects a complete framework from the data link layer, and it encodes as a series of signals that are transmitted to the local media, and the encoded bits that comprise a frame are received by either an end device, either an intermediate device, and other devices. So the destination node physical layer retrieves these individual signals from the media and restores them to their bits representations, and uh, passes the bits up the data link layer as a complete framework. Now, physical layer characteristics. So, in the previous topic, you gained a high level overview of the physical layer and its place in a network. And this topic a bit deeper into the specific of the physical layer, right? So, this includes the components and the media used to build a network, as well as the standard that are required so that everything work together. And the protocols and operations of the upper OSI layer are performed using software designed by software engineers and computer scientists basically. And the services are and protocols in the TCP/IP suite are defined by the Internet Engineering Task Force, as known as IETF. So the physical layer consists of electronic media and connectors developed by engineers, and therefore it is appropriate that the standards this hardware are defined by the relevant electrical and communication engineering organizations. There are many different international and national organizations, regularly government organizations, private companies involved in establishing and the maintaining physical layer standards. For instance, the physical layer hardware, media, encoding, and signaling standards are defined and governed by these standards like ISO, like TIA, like ITU, IEEE, and ANSI, and other organizations. So, in addition to these, there are often regional cabling standards such as CSI, Canadian Standards Association, and GSA, GIS, Japanese Standards Association, which develop local specifications, right? So, physical components are address three functional areas: physical components, encoding, and also the signaling. Basically, physical components are the electronic hardware devices, media, and other connectors that transmit the signals that represent the bits. And hardware components such as NIC, interface, and connectors, cable materials, and cable designs are all specific in standards associated with the physical layer. And the various ports and interfaces on a Cisco router are also example of the physical components with the specific connectors on the resulting from the standards. Now encoding. Now encoding. Basically, encoding or line encoding is a method of converting a stream of data bits into a predefined code. So, codes are grouping of bits used to provide a predictive pattern that can be recognized by both the sender and the receiver. In other words, we can say encoding is the method or pattern used to represent the digital information. So this is similar to how the code encodes a message using a series of dots and dashes. For example, uh, encoding represent a 0 bit by a high to low voltage transmission, and a 1 bit is represented as a low of the high voltage transmission. So in example of encoding is illustrated in this figure. The transition occurs at the middle of each bit period, and this type of encoding is used in 10 Mbps Ethernet, and faster data rates require more complex encoding. And encoding is used in older Ethernet standards such as 10 base T and Ethernet 100 base TX, and uses some other encoding and the encoding techniques. Now signaling. So the physical layer must generate the electrical, optical, and wireless signals that represent the 1 and 0 on the media, and the way that bits are represented is called the signaling method. So the physical layer standards must define what type of signal represents and 1, and what type of signal represents 0. So this can be as simple as a change in the level of an electrical signal or optical pulse. For example, a long pulse might represent a 1, whereas a short pulse might represent a 0. So this is similar to the signaling method used in Morse code, and which may use a series of an off tones. Now bandwidth. So basically, different physical media support the transfer of bits at different rate, and data transfer is usually discussed in terms of the bandwidth. So bandwidth is the capacity at which a medium can carry the data, and digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. So bandwidth is typically measured in kilobits per second, kbps, and also measured in Mbps, megabits per second, or also in used for gigabits per second. So bandwidth is sometimes thought of as a speed that bits travel. However, this is the not accurate. For example, in both 10 Mbps and 100 Mbps Ethernet, the bits are sent at the speed of electricity, and the difference is the number of bits that are transmitted per second. So basically, a combination of factors determine the practical bandwidth of a network and the properties of physical media and the technologies that can be used for this. So now coming on the bandwidth terminology, terms used to measure the quality of bandwidth include the latency and throughput and goodput. So latency refers to the amount of time, including the delay of for data to travel from one given point to another. In a network, internetwork or network with multiple segments, so throughput cannot be faster than the slower link in the pattern from source to destination. Even if all or most of the segment have high bandwidth, it will be only take one segment in the path will low throughput to create a bottleneck in the throughput of the entire network, right? So basically throughput is the measure of the transfer of bits across the media over a given period of time. Due to a number of factors, throughput usually does not match the specific and specified bandwidth in physical layer, and throughput is usually lower than the bandwidth. As I mentioned, there are many factors that influence throughput, as the amount of traffic, the type of traffic, and the latency created by the number of network devices, and other some factors, right? So there are many online speed tests that can reveal the throughput of an internet connection. And good put, there is third measurement to access the transfer of usable data. It is known as a good put, and good put is the measure of usually data transferred over a given period of time, and good put is throughput minus traffic overhead for establishing the seasons and acknowledgements and encapsulations and the retransmission bits. So good put is always lower than throughput, which is generally lower than the bandwidth. Our third objective is the copper cabling. So copper cabling is the most common type of cabling used in networks today. In fact, copper cabling is not just one type of cabling. There are three different type of copper cabling that are each used in specific situations, right? So networks use copper media because it is inexpensive, easy to install, and has low resistance to electrical current. However, the copper media is limited by distance and signal interface, right? So the data is transmitted on copper cables as electrical pulses, and a detector in the network interface of a destination device must receive a signal that can be successfully decoded to match the signal sent. However, the further the signal travels, the more it uh, referred to as a signal attenuation. For this reason, all copper media must follow the strict destinate distance and limitations, and the specified by the guiding standards. So there are three main types of copper media used in networking: UTP, STP, and coaxial cable. Basically, UTP cabling is the most common networking media, and UTP cabling terminated with RJ45 connectors is used for the interconnecting network host with intermediately networking devices such as switches, such as routers, right? So in local area networks, UTP cable consists of four pairs of color coded wires that have been twisted together and then encapsulate in a flexible plastic sheet that protect from minor physical damage. So the twisting of wires help protect again the signal interface from other switches. As you can see in this figure, the color codes identify the individual pairs and wires and add in basically cable termination, right? So so the numbers in this figure identify some key characteristics of unshielded twisted pair cable. Number one is the outer jacket protect the copper wires from physical damage. Number two is twisted pairs protect the signal from interference. And number three is the color coded plastic insulation electrically isolated wires from each other in identifies the each pair. Now STP, shield twisted pair. Basically, it provides the better noise protection than UTP cable. However, the compared to UTP cable, STP cable is the significantly more expensive and more difficult to install like UTP cable, like STP uses. So basically, STP uses an RJ45 connector, and it combines the techniques of shielding to the counter RFI and wires twisting to a counter crosstalk to gain the full benefit of the shielding, right? So STP cables are terminated with the special shield STP data connector if the cable is improperly grounded. The shield may act as an antenna and pick up unwanted signals. So the number in this figure identify the some key features. Number one is outer jacket, number two is braided or full shield, and number three is fall sheets, and number four is twisted pairs. Now coaxial cable, basically it gets its name from the fact that there are two conductors that share the same axis. So a copper conductor is used to transmit the electronic signals, and a layer of flexible plastic isolation surrounds a copper conductor, and the insulating material is surrounded in a basically that acts at the second wire in the circuit and as a shield of the inner conductor. This second layer or shield also reduces the amount of outside electromagnetic interface, and the entire cable is covered with a cable jacket to the minor physical damage. There are different types of connectors used with coaxial cable, BNC, N-type, F-type connector, and although UTP cables have essentially replaced coaxial cable in modern Ethernet installations, and the coaxial cable design is used in the following situation. Number one is wireless installations, and number two is the cable internet installations. Now UTP cabling. So in the previous topic, you learned a bit about unshielded twisted pair, UTP copper cabling, because UTP cabling is the standard for the use in LANs, local area network. So this topic goes into details about its advantages and limitations and what can be done to avoid the problems. When used as a networking medium, UTP cabling consists of four pairs of color-coded copper wires that have been twisted together and then encapsulate in a flexible plastic shield. So its small size can be advantage and during installation, and UTP cable does not use shielding to counter the effect of instead. So, cable designers have discovered other ways that they can limit the negative effect of crosstalk. It can be used as a cancellation, and number two, varying the number of consist per wire pair. So, UTP cable relies these solely on the basically cancellation effect produced by the twisted wire pairs to limit the signal efficiency and provide self-shielding for wire pairs within the network media. UTP cabling standards and connectors. So, UTP cabling conforms to the standard establishment by the TIA, especially TIA, uh, uh, the commercial cabling standards for LAN installation, and is the standard most commonly used in LAN cabling environment. Some of the element defined as follow. It can be used in cable types, cable lengths, connectors, terminations, and methods of testing code. So, the electrical characteristics of copper cabling are defined by the Institute of Electrical and Electronic Engineering, known as IEEE. So, IEEE rates the UTP cabling according to its performance, and cables are placed into the categories based on their ability to carry the higher bandwidth rates. For example, Category 5 cable is used commonly in 10 base TX, 100 base TX for fast Ethernet, and other categories including the enhanced Category 5 cables, Category 6 and Category 6A. So cable in higher categories are designed and constructed to support higher data rates as new gigabit speed Ethernet technologies are being developed and adopted. So the figure shows three categories of UTP cable, and category 3 was originally used for voice communication over voice lines but later used for data transmission, and category 5 and 5E is used for the basically data transmission, and category 5 supports 100 Mbps and category 5E supports the 1000 Mbps, and category 6 has an added separator between each wire pair to support the higher speed, and category 6 support up to 10 gigabits, and finally category 7 also supports the 10 gigabits and category 8 supports the 40 gigabits. So basically UTP cable is usually terminated with an RJ45 connector, as I described previously. So RJ45 connector is the male components crimped at the end of cable. So the socket shown in this figure is the female component of a network device wall and a patch panel. When terminating the each cable is source of physical layer performance. Now straight through and crossover UTP cables. Different situations may require UTP cables to be wired according to different wiring connectors, and this means that the individual wires in the cable have to be connected in different orders, different set of pins in RJ45 connectors. So the following are the main cable types that are obtained by using specific wiring conventions. Number one is Ethernet straight through, and number two is Ethernet crossover. Ethernet straight through, the most common type of networking cable. It is commonly used to interconnect a host to a switch and a switch to a router. And Ethernet crossover cable is used to interconnect similar devices, for example, to connect switch to switch, host to a host, router to a router. And however, crossover cables are now considered legacy, as NICs use medium dependent interface crossover, means auto MDIX. It used to automatically detect the cable types and make the internal connectors. So, using a crossover or straight through cables, interconnectivity between devices may not damage the devices, and but definitely connectivity and communication between the devices will not take places. This is a common error, and checking that device connectors are correct should be the first troubleshooting action if connectivity is not achieved. Now, fiber optics cabling. As you have learned, fiber optic cabling is the other type of cabling used in networks because it is expensive. It is not as commonly used as the various type of copper cabling, but fiber optic cabling has certain properties that make it the best option in certain situation, what you will discover in this topic. So a fiber optics cable transmit the data over longer distance and at higher bandwidth than any other networking media. Unlike copper wires, fiber optic cable can transmit signals with the less attenuation and is completely immune to EMI and also for RFI. So fiber optics, yeah. So optical fiber is commonly used to interconnect network devices, and optical fiber is a flexible but extremely thin. Now, types of fiber optics. Basically, fiber optic cables are broadly classified into two types: single mode fiber and multi mode fiber. Single mode fiber consists of a very small core and uses expensive laser technology to send a single ray of light. And single mode fiber is popular to in long distance situations and such as those required in long haul telephony and cable TV applications, right? So one of the highlighted difference between both of them is the amount of dispersion, and dispersion refers to the spreading out of a light pulse over time. So increase the has a greater dispersion that SMF. That is why an MMF can only travel up to 500 meters before the signal loss. Now fiber optics usage. So it can be used in five types of industry: enterprise network, fiber to the home network, and long haul network, and some submarine cable networks. Now fiber optics connectors. An optical fiber connectors terminate the end of an optical fiber, and variety of the optical fiber connectors are available. The main difference among the types of connectors are the method of coupling basically. So business decide on the type of connectors that will be used based on their equipment. Some switches and routers have ports that support fiber optics connectors through a small form factor SFP. Kindly search out the internet for various types of SFPs. Now, wireless media. Basically, you may be taking this course using a tablet or a smartphone. This is only possible due to wireless media, which is the third way to connect to the physical layer of a network. So, wireless media carry the electromagnetic signal that represent the binary digits of data communication using radio or microwave frequencies. And wireless media provide the greatest mobility options of all media, and the number of wireless enabled devices continue to the increases. So wireless is now the primary way users connect to home and enterprise networks, and these are the some of the limitations of wireless. Number one is coverage area. Number two is interference. Number three is security, and number four is shared medium. Although wireless is increasing in popularity for desktop connectivity, and copper and fiber are the most popular physical layer media for development and for deployment also for the intermediate network devices such as routers, such as switches and others. Now types of media wireless. The IEEE and telecommunications standards the for wireless data communication cover both the data link and physical layers. In each of these standards, physical layer specifications are applied to area that including the following. Number one is data to radio signal encoding. Number two is frequency and power of transmission. And number three is signal reception and the decoding requirements. And number four is antenna design and construction. So there are the several wireless standards like Wi-Fi, like Bluetooth, like WiMAX, like Zigbee, and other. So other wireless technologies such as cellular and satellite communication can also provide data network connectivity. However, these wireless technologies are out of scope for this module.